Density. Density is mass over volume. So if we would take an object and get its mass, it would have a certain volume. And if we change the mass, the volume would change, and it would be a linear approach. And if we graph it, we would get a straight line, and the slope of this line is equal to the density. Because density is mass divided by volume, and if we rearrange to get the volume off the bottom of the fraction, we get mass is equal to density times volume, and that relates to y equals mx plus b. And then to find the slope, to remember how to find the slope, I highly recommend is you take points that are on the two extremes of the graph. And we can call these points x1, y1 for its coordinates, and x2, y2 for this coordinates here. And to find the slope, and slope is equal to m, which is equal to density, we can take rise over run. And the rise then would be change in y over change in x, which is then y2 minus y1 all over x2 minus x1, coming from the points on the two extremes. When doing slope, you always want to take the two extremes like I'm doing there. Don't take points that are on the line, but you want the average of the whole line, so you go to the two extremes. And since the y-axis was mass in grams, this is going to be grams, and the x-axis is volume in milliliters. So we have milliliters here. So that's one way of finding the density. Quite often we will use an approach known as water displacement, where we have a graduated cylinder. It has water in it, x volume amount of water. This is your initial volume. When you put something in it, so we put some coins in it, the volume level is going to go up due to that. So that would be, we'll call that V1. And then if we put more coins in it, we get a different color yet, the volume then is going to go up even higher, and then that volume would be V2. So then to find the change in volume, it's going to be V2 minus V1 for that given mass. To work a couple problems using density, let's say we have an object that has a mass of 25.0 grams, and it occupies a volume of 6.3 milliliters. And we want to determine the density. Density is mass over volume. The mass of the object is 25.0 grams, and its volume then is 6.3 milliliters. So in other words, if we actually did the graduated cylinder, going back to the cylinder, we started out with so many milliliters. When we added the solid to it, when we added 25 grams of solid to it, or whatever, we'll call it solid, the volume increased. This change was 6.3 milliliters. So then to find the density, we just take the 25.0 divided by 6.3. Got my handy candy calculator. Got to turn it on. 25 divided by 6.3. And we have 2 sig figs. So the answer that I have density wise, I just turned my calculator off, was 3.9682 grams per milliliter. Since we have 2 sig figs, the answer then would be 4.0 grams per milliliter. With density, you should be able to work this equation and solve for any component in the density. You want to be careful of the units. for most solids and liquids, the units are grams per milliliter or kilograms per liter for the units. And for gases, quite often it's grams per liter for gases. And just a footnote, a milliliter is the same thing as a cubic centimeter.